So what we have here are the two stress strain diagrams for two types of ductile material. So what is a ductile material? You might have heard me mention brittle material in the last video. It's a very simple distinction between a ductile and a brittle material. So a ductile material, oops, that's not what we wanted. Let's go back here. A ductile material is one that will plastically deform. A brittle material will not. A brittle material, as soon as you leave the elastic region, will shatter. It will break. And we'll talk about that here in a second. So let's talk about ductile material. So ductile material will have a elastic region. So now if I take a look at this, I have a low carbon steel and aluminum alloy here. The couple things to point out as I look at the stress strain diagram for the ductile material, the low carbon steel, you'll see, oh, look, there's that little bump. So that would be our elastic limit. But we do not define the yield stress based off that. We use our 0.2% offset yield, which if I erase this little line here, you can see that it's at a different point than the elastic limit. We have the yielding, the strain hardening, and the necking region. Now, if I go over here and look at the aluminum's a little bit more typical. There is no yielding region. It goes right into strain hardening. And so it just completely skips that entire concept of yielding, goes right into it. That's why we don't have that bump to define the end of the elastic limit. Now, as I go and I look at this, let's look at how they fail. So a ductile material, you'll see that this is the necking. This is where it starts to locally reduce. And then when it finally does fail, it pops like this. And actually it's called a cup and cone fracture, because you're not going to really be able to see it here, but if you look on the one side, you'll see this in the lab, it will be, let's do my amazing drawing, you will have a cone on the one side. It'll be circular, and then on the other side, it'll be the little cup that it sits into. Now, it's pretty interesting, because as you start looking at failure mechanics, you can kind of tell a couple things about a material if you know the way that it fails. And so with this one here, the cup and cone, that's when you look at it and go, oh, I know that this was a ductile material that failed within the tensile, the normal strength, that we pulled on it like this, because it's the only time that a cup and cone appears. Now, so that's the ductile material. So the brittle material, what happens with the brittle material? There is no plastic deformation. We get right to the end of the linear elastic region, and then it's done. It breaks. There is no plastic deformation. So the interesting thing here is if you look at the way it breaks, since there is no plastic deformation, it just breaks completely straight across linearly. And I say this is interesting because this is a brittle material, it breaks like this. A ductile material, when it fails in torsion, breaks the exact same way. So it's kind of interesting the way things are going on. Now, for the brittle materials, let's go back to our stress strain diagram of a couple slides ago. And so we talked about the strain hardening region. Now, one of the things that happens within this strain hardening region is we make the material more brittle. So if we strain harden it too much, release it and go to use it, what happens now is the next time that you apply the load to it, it may become so brittle that it completely acts like a brittle material, and if you have any deformation on it at all, it's going to break. And so those are just things to keep in mind. So the biggest thing to remember, the big difference between between a brittle material and a ductile material is that entire concept of plastic deformation. If it can plastically deform, it's a ductile material. If it cannot plastically deform, it is brittle.